Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's discussion, we'll be talking about how do we predict insurance cost given a set of demographic details. Even before I proceed to build a linear regression model for this particular data set, I request all of you to like, share, subscribe, and press the bell icon. In this data set, I have got approximately 1,338 records. And I've got demographic details like age, gender, body mass index, number of children, whether a person is a smoker or not, then the region which he comes from. And the last variable that I have is the insurance cost. We want to predict the insurance cost. So we will be using the variable charges as the dependent variable. To build a linear regression model in STATCRAFT, let's first click on the Analyze menu, scroll down. You can see the option regression. Let me click on the drop-down menu. Within regression, the second option here is linear regression. Let me click on the option linear regression. As you can see here, what STATCRAFT does is it displays all the variables that are present in the data set in the canvas on the left-hand side. Along the dependent variable, what I will do is I'll choose the variable charges. When it comes to the independent variables, I'll choose the variable age, then I'll choose the variable body mass index, the number of children, and then I'll also choose variables like gender and smoker. I did not choose the original variable for gender and smoker because they were string, they were not numerical data, and therefore gender 1 and smoker 1 is what I have taken along the independent variables. So given these set of predictors, we want to estimate what is the predicted insurance cost. Let me go ahead and click on OK. It takes a couple of moments for STATCRAFT to show the output. You can see here in the output window, STATCRAFT shows the R code which is used, which it has used to generate the linear regression model. The first metric that we see here is what is called as R-square. It's also called as coefficient of determination. R-square always lies between 0 and 1. If the value is close to 1, it means that the model fits the data well. If the value is close to 0, it means that the model does not fit the data well. R-square is also popularly called as coefficient of determination. You can see here the R-square value is 0.59, which simply means that roughly 59% of the variation in the dependent variable is explained by the set of independent variables that we have taken. Along with R-square, we also see another metric which is called as adjusted R-square. Adjusted R-square is useful when you want to compare two different models, and adjusted R-square penalizes a model for having additional variables. Let me scroll down. The second table that you see that STATCRAFT displays is what is called as the parameter estimate table, or simply the coefficients table. You can see here the value of the intercept is being shown, and for each of the 5 variables, STATCRAFT is showing the unstandardized coefficient for each variable. For the variable age, the unstandardized estimate is $237. What does this mean? This means that if age increases by 1 year, the expected medical cost goes up by $237. Similarly, if body mass index goes up by 1 unit, the expected medical cost goes up by $68. Similarly, the same interpretation can be made for the variables gender and the other variables. When you look at the p-value, the p-value for each of these variables is very small. As you can see here, the p-value for age is less than 0.05, which means that the coefficient for age is significant. Age is a useful predictor which drives the medical cost. The same thing can be told about BMI because the p-value here is less than 0.05. The variable children, the number of children that the beneficiary has also has a p-value less than 0.05. So all these variables are highly significant. Finally, what we see here is the ANOVA table. You can see here, STATCRAFT displays the F statistic value, the regression degrees of freedom, as well as the residual degrees of freedom. And finally, it shows the p-value. The p-value here is very, very negligible. In fact, it is smaller than 0.05, and therefore we can conclude by saying that the F statistic is significant. So this brings me to the end of today's video. In today's video, we have seen how to build a forecasting model to predict insurance cost. We've used linear regression model, and we have generated R-square, adjusted R-square. We've also generated the p-value for each of the independent variables. If you have liked this video, I request you to kindly press the like button. Thank you very much for watching this video. Have a great day ahead.